Hello friends, welcome back to another episode on exciting careers in power systems industry. In today's episode, we are going to discuss opportunities for electrical engineers in the reliability space. If you're working in the power systems industry, you would have come across job titles such as electrical maintenance engineer, electrical reliability engineer, and so on. So what are the different responsibilities that are carried out by electrical reliability engineers? What are the requirements and qualifications? What can you expect in your day-to-day role as an electrical reliability engineer? And last but not the least, what are the career prospects and growth opportunities as an electrical reliability engineer? In an industrial setting, typically the role of a reliability engineer is carried by electrical engineers or mechanical engineers. Let us imagine a heavy industry setting. For example, oil and gas, automotive, mining and metal, pharmaceuticals, steel making, smelting, manufacturing, and so on. All of these settings contain a lot of mechanical and electrical equipment. There are multiple systems and processes that are working simultaneously. The role of a reliability engineer is to make sure that proper maintenance is being done for every equipment, and in case there is a breakdown, you have a plan in place to address it. You also have to be proactive in terms of monitoring and data acquisition. Always maintain a list of high risk, high consequence, high impact points within a system and develop contingency planning. This in a nutshell is what a typical reliability engineer would be responsible for. They are also expected to come up with innovative solutions when it comes to equipment reliability and maintenance. Electrical reliability engineers are expected to create a priority list, as I mentioned earlier, and in order to have a hit list of key assets, you need to have a good understanding of the power system. Typically, the higher up in the power system network that you go, the more upstream you go, the more critical an asset becomes. So let us imagine that we have a single line diagram, and let's start from the bottom. You have electrical panels, you have end loads, receptacles, motors, lighting, heating elements, pumps, elevators, and so on. One level up, you have the panels or the distribution boards that are feeding these loads, or the motor control centers. One level up, you have the low voltage switchgear is feeding multiple MCCs or distribution boards, and you go one level up and you have a medium voltage switchgear which is being fed by a transformer that has a medium voltage secondary. And one level up, you have the transformer with the service entrance coming from utility. This is a very common, typical distribution scheme in any industrial or commercial setup. Now, if a distribution board fails, which is feeding a lighting panel, or the lighting panel fails, then it's not a big deal, generally speaking. Worst case scenario, you will lose power to a handful of receptacles and lighting might go off. None of this will hopefully be critical or crucial. But let's say if you knock out an entire MCC, which is one level above this distribution board, then you're taking out multiple motors. Some of these motors can be part of critical processes. And if we go even one level above that, at the low voltage switchgear level, and you lose the entire switchgear, then you're entering a dangerous zone. Why? Because the switchgear is probably feeding multiple MCCs, and each MCC, let's say hypothetically, is feeding 10 motors, and this switchgear is feeding 5 MCCs, then you potentially have 50 motors out of service. So with this logic, you can see that generally speaking, critical assets are at the medium voltage or the high voltage level. Sometimes your low voltage equipment distribution boards can also be classified as critical assets depending on the loads that they're serving. And that's the reason why when we have some critical loads in the form of control power, data centers, communication equipment, we generally back it up by means of a UPS or an emergency generator, and sometimes a combination of the two. So I'm not saying that the low voltage distribution, low voltage equipment, low voltage assets are not critical. It's just that losing a medium voltage or high voltage asset typically results in a greater collateral damage. So as an electrical reliability engineer, you'll have a hit list of all of these critical assets, and you'll be paying a lot of attention to the performance and any type of issues related to your medium voltage transformers, medium voltage switchgears, your variable speed drives, your MCCs. You can install temperature monitoring, noise detection, arc flash detection, and get real-time feedback using instruments to a central SCADA system or a PLC network. You can incorporate thresholds that if the temperature on this particular winding of this particular transformer exceeds this level, then notify me on my cell phone. Send me a text message, send me an email, have some sort of alarms triggered. And by actively monitoring critical assets, you're reducing the probability of a catastrophic failure that can take out an entire section of a process or a plant. I've had some students who work for electrical utilities, large electrical utilities in Texas, and as part of continuous improvement, they created softwares and spreadsheets to better track simple things such as usage of SF6 gas, breaker maintenance, because a lot of these electrical equipment work on a schedule. After so many years, you should actually take the breakers out and get them repaired and looked at. Similarly, if you don't have online dissolved gas analysis installed on oil-filled transformers, you probably have to take oil samples every year and send them to lab in order to see what is the content and composition of the transformer oil, because that can help you identify whether there is any indication of premature failure. Now let's talk a little bit about the requirements and the qualifications and the skills that employers are looking for when it comes to electrical reliability engineering roles. As far as the academic side of things is concerned, you're expected to have at least 4 years of undergraduate electrical engineering degree. A lot of employers also value FE/EIT certification and a PE license. If you have an EIT certificate and looking to make an entry into this type of a role, then it can help you stand out from the rest of the crowd. And if you already have a PE license, then you'll be in a very exclusive group. As you probably know, I help students prepare for FE electrical and computer exam and the PE power exam. In order to become a licensed engineer in the US, you have to pass both of these exams. The first one is FE and the second one is PE. If you want to learn more about my FE electrical and computer exam preparation programs, please visit my website studyforfe.com. I've also authored several books on the topic of FE electrical and PE power exam preparation. A lot of employers are looking for hands-on field experience because reliability engineering role entails a lot of site visits. Now, some of the engineers really look forward to hands-on engineering, whereas other engineers prefer office type of a setting. I think it goes without saying, if you want to be a reliability engineer, you have to spend a lot of time in the field. You have to get up close and personal with equipment. You have to become comfortable using the tools. You have to interact with professionals with a wide range of skills: electricians, mechanical engineers, operators, control engineers, technicians, technologists, project managers, end users, and maybe even clients and customers. If you happen to have training on some of the equipment, then that can be a big plus as well. For example, if you have commissioned variable speed drives, if you have experience with different types of MCCs, such as Allen Bradley MCCs, ABB MCCs, if you have installed some UPSs and participated in the startup and commissioning of certain UPSs, such as Gutor, Schneider Electric, if you have experienced troubleshooting different types of relays, all of these skills will increase your odds of success in this role. And if you have hands-on experience, it will be music to the ears of potential employers who are trying to fill electrical reliability engineering roles. And if you want to learn more about preparation of FE electrical and computer exam and the PE power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.